Hello everyone, my name is Priya Singh Rangey. I'm an assistant professor at the Rangey Institute of Physiotherapy, and today we'll be talking about conductors and insulators. So we'll be learning about what are different conductors, what are the properties of conductors, what are insulators, and what are the different properties of insulators. So beginning with what are conductors. Conductors are basically materials that allow free flow of electrons from one particle to another. So there is lesser resistance to the flow of electrons in these materials. These materials easily allow the electrons from their valence orbitals to move out of the orbits and to move about freely within the conducting material. The outer electrons can easily move out of the atom because they are loosely bound. The attraction force with the nucleus is quite less, and hence they are loosely bound to the atom, and so these electrons can easily move out of their orbitals and they can travel about in the material as free electrons. These kind of conductors are usually metals like copper, aqueous solutions of different salts like sodium chloride, and the human body. The human body is also a conductor. The conductivity is much less if you compare it to a metal, but the human body, because of the build-up, is something that gives conductivity. Next, moving on to the properties of a conductor. A conductor provides less resistance towards the flow of electricity since the electrons are very loosely bound to the orbit, to the atom. They can be easily taken out from the atoms and they can easily move about in the conductor, and hence there is a less resistance towards the flow of electricity, because ultimately when we talk about electricity is just the flow of electrons. So there is less resistance towards the flow of electricity in a conductor. Whenever there is an alternating current that is passing through a conductor, because of the alternating current there is going to be a magnetic flux that is going to be generated around the conducting material. This magnetic flux can be of two types. There can be an internal flux and there can be an external flux. Because of the difference between these two flux, that is the internal and the external flux, there is going to be an inductance of the electric current into any other conducting material that may be present in the vicinity of the said conducting material. So a conductor also possesses the property of inductance. When we talk about a conductor, there is free charge of electrons whenever electricity is passing through that conductor. When we say that electricity is passing, we mean that there is a flow of electrons. Since the electrons are negatively charged, there is going to be a huge repulsion force that is going to exist between these electrons. Because of this electrostatic repulsion, the electrons are going to move to the surface of the conductor rather than staying inside the conductor, because the resistance, the repulsion between the two electrons is going to be larger if they are going to stay inside the conductor. Hence what happens is that all the electrons move to the surface of the conductor, and hence we can say that all the free charge gets accumulated on the surface of the conductor. Because of this free charge lying on the external surface or the outer surface of the conductor, there is zero electric field that is present inside of the conductor. If we are talking about a perfect conductor is not going to have any electric field inside it. All the electric field, since the free charge is lying on the surface of the conductor, all the electric field is going to lie in the vicinity of the conductor or on the surface of the conductor, but not within the conductor. And because of the same reasons, the charge density inside the conductor is going to be zero, because there is no free charge that is lying inside the conductor, and since there is no free charge, there is going to be no charge density inside the conductor. The electric field that is generated here in the conductor is going to lie in a normal direction, that is, it is going to lie perpendicular to the surface of the conductor. As we know that electric field is always going to be in a direction perpendicular to the direction of flow of electrons. So hence electric field is going to lie normal to the surface of electrons, because all the electrons are going to move along the surface of the conductor. So these are the properties of a conductor. Next, moving on to an insulator. What is an insulator? An insulator is a material that impedes the flow of electrons from one particle to another. So this is something that's opposite of what a conducting material does. An insulating material, unlike the conducting material, is going to impede the flow of electrons. As we have seen in a conductor is going to allow the flow of electrons, but here in an insulator it is going to impede or restrict the flow of electrons. The use of insulators is that, as in a conductors we use for the flow of electricity or the flow of heat, but an insulator can be used in order to prevent the transfer of charge from the conductor to the other surfaces. So if we do not want the charge to flow from the conductor into the vicinity, if any other conducting material is lying nearby, then we can use an insulating material around that conductor. So we can reduce the flow of charge or reduce the charge from flowing to another conducting material. There are various types of insulators like a plastic, a rubber, air, etc. Next, moving on to the properties of insulators, like conductors have some properties. In the same manner, insulating materials also have some properties. Like, insulating materials provide high resistance against the flow of electricity. As we have seen in conductors are going to apply very less amount of resistance, but with insulators the amount of resistance to the flow of electricity is going to be very high. The reason for this is that insulating materials do not have electrons that are very loosely bound. They have valence electrons that are very tightly bound to the nucleus of the atom. And since these electrons are tightly bound, it becomes very difficult to remove those electrons from the orbitals and allow them to flow freely in the material. Hence, we can say that it provides high resistance against the flow of electricity. And this insulating material, when we are connecting it to a high voltage that is much higher than the dielectric strength of the insulating material, if we are providing quite high voltage, then the insulating material may change its properties. The electrons may possess that force which may be able to get them out of the orbitals, and these insulating materials may then be able to conduct heat and electricity. So these are the properties of insulators, that they provide high resistance against the flow of electricity, they have valence electrons that are tightly bound, and they can conduct heat and electricity when they are connected to high voltages. So this was all about insulators and conductors. My next video is going to be on the semiconductors, and you can refer that as well. So we cover conductors, semiconductors and insulators all together. Thank you.